Robinhood Capacity Planning with AI. So, this is about real world case study, how AI helped, where it went wrong, and how we fix it. So, this is about a capacity planning with AI. So, how it helped in creating the capacity plan and where it went wrong and how we fixed it. So, let's start with this presentation today. So, section one is about Robinhood, its overview and the objective over here. We are going to do with the Robinhood. Now, this document is a complete case study of using AI, that is Claude, to perform capacity planning for Robinhood, the retail trading platform that democratized commission-free investing. It demonstrates exactly how AI assists an engineer where AI produces incorrect output and how a trained professional corrects those errors. Moreover, this is not just a capacity plan, it is a live demonstration of the correct workflow for AI assisted system design. That is, AI is the first draft engine, human expertise as a validation and correction layer. But first of all, there are some key facts about Robinhood. What is a Robinhood? You know, so Robinhood was founded by Vlad Tenev and Baiju Bhatt, two Stanford roommates. Yeah, two Stanford roommates built Robinhood in 2013 with one goal: let ordinary people invest in stocks without paying expensive broker fees. Now, their business model is commission free trading, that is, revenue via PFOF, gold subscriptions, interest. Robinhood charges zero to trade. But Robinhood makes money by selling your orders to market makers. For example, Citadel. They have an agreement with Citadel, the hedge fund, charging $5 a month for premium features and earn interest on uninvested cash sitting in customers' account. Then we have funded accounts. Now, 25.2 million in 2024 and then 27.2 million as of Jan 2026. As of Jan 2026. Now, this 25.2 million people have deposited real money into a Robinhood account. These are not just app downloads, these are people with actual funds ready to invest. Then we have monthly active users, that is 13 million since 13 million according to quarter 4 2025. Out of all funded account holders, 13 million actually logged in and used the app at least once during the month. The rest have accounts but are not currently active. Now, 2024 net revenue. Robinhood earned nearly $3 billion in 2024, and that revenue grew by more than half compared to the previous year, driven largely by crypto trading boom. Then we have 2024 net income. So 2024 net income was $1.41 billion, first full profitable year. So after years of losing money, 2024 was the first complete year where Robinhood kept more money than it spent, a major milestone that proved the business model actually works at scale. Asset under custody or asset under management. So they have around $193 billion by the end of 2024. And then as of Jan 2026, it is $324 billion. So this $193 billion worth of stocks, crypto, and cash belonging to customers is sitting inside Robinhood's platform. Robinhood does not own this money, it safeguards it on behalf of its users. Now, they have plenty of products. Some of them are stocks, ETFs, options, futures, cryptos, retirement. Robinhood has expanded far beyond just stocks. You can now trade complex financial instruments like options and futures, buy Bitcoin, or even invest in retirement account, all from one app, that is Robinhood. Now, then comes settlement standard. T1 since May 2024. Now, when you sell shares today, the money officially arrives in your account the next business day, not 2 days later. Earlier, it was 2 days later, that is T plus 2. But SEC changed the rule on 2024, on May 28, 2024. So it is now that money officially arrives in your account the next business day. Tech stack. So the tech stack that they use is AWS, Kubernetes, PostgreSQL, Redis, Kafka, Python Go. So Robinhood run its entire platform on Amazon's cloud, uses Kubernetes to manage its servers, PostgreSQL to store trade data, Redis for fast caching, Kafka for real-time event streaming, and Python plus Go as its main programming language. So this was about Robinhood, the company. Next comes section 2, AI workflow and the 5 prompts that we have used. Now this AI workflow. So before writing a single prompt, a structured workflow was designed. AI was not used as an oracle, it was used as a first draft engine to produce complete but unvalidated plan quickly, which a human expert then verified and corrected. So the prompts that is used to generate the capacity plan. So I'll go about these prompts one by one and try to explain what these prompts are really doing. So the first prompt is assumption and scale. So as it says that you are a senior system architect. Robinhood is a retail trading platform with 25 million funded accounts and approximately 13 million monthly active users in 2025. So estimate daily active users, average trades per day in normal conditions, peak trades per day during extreme events like GameStop Jan 2021, then read to write ratio for the order management system, then QPS at normal and peak loads. Explain your reasoning for each assumptions. So what I am asking here through this prompt, the first prompt, is that you are playing a role of a senior architect who needs to plan Robinhood's infrastructure. The entire prompt is asking for give me the traffic numbers so I can start planning. The second prompt is storage planning. Now, given Robinhood's processes, equity, options, and crypto trades for 25 million accounts, estimate daily storage growth for order records in PostgreSQL, market data time series feeds, audit logs with 7 years SEC retention requirement, and user portfolio snapshots. Including replication factor, index overhead, and a 5-year storage projection assuming 40% annual trade volume growth. So here I'm asking AI to calculate how much storage Robinhood's 4 main data types consume daily, and then project that forward 5 years as business grows. Now prompt 3 is about bandwidth and traffic. Calculate streaming bandwidth requirement with Robinhood. Calculate streaming bandwidth for Robinhood. Include market data feed, inbound bandwidth, order API traffic, WebSocket connections for real-time price updates, and peak traffic during meme stock events, that is 10 to 50x spikes. So here I'm asking AI to calculate how much data flows into Robinhood from exchanges, how much flows out to users through orders and live price streams, and what all those numbers become when a meme stock such as GameStop event hits using Robinhood's own documented traffic spike as a reference point. Now, then the prompt 4 is database and infrastructure. Now I'm asking AI over here that design the database architecture for Robinhood Order Management, include sharding strategy, read replicas, caching layer with Redis, Kafka for event streaming, and Postgres capacity requirements. So here I have asked AI to design the complete data infrastructure, database sharding, caching, event streaming, and read replicas, connection management, that can survive 750,000 requests per second based on Robinhood's own documented peak load. Then last but not the least is the last prompt that says cost estimation and AI usage. Here I asked to estimate monthly AWS infrastructure cost for Robinhood at current scale. Also describes how AI ML is used in the platform, fraud detection, order routing, optimization, risk assessment, and personalized recommendations. So I've asked AI to translate the entire capacity plan into monthly dollar figure broken down by infrastructure category and separately explain how Robinhood uses machine learning inside its own product across four specific functions. Then here comes the AI response summary. So what this table is doing? What this table is doing? I have given Claude 5 prompts over here, 5 prompts. So Claude came back with a complete capacity plan. Now I'm sitting with a plan and checking every number against real Robinhood data. This table, this table is a result of that checking. For each output, you're answering 3 questions. What did AI say? Is it correct? And how wrong is if it is incorrect? So over here, I'll be talking only about the incorrect validation status, not the correct status, because those are the ones that we need to check. What did AI say? And how wrong is it if it is incorrect? So first one is daily active users. Now, as you can see over here, according to AI, daily active users are 8 to 10 million. Now, this is incorrect. This is incorrect. AI said roughly 9 million people uses Robinhood daily. The real number, but the real number is closer to 4.7 million. Now, AI doubled the actual figure by using social media benchmark instead of a trading app benchmark. Every traffic calculation built on this number was therefore also doubled. Then comes peak trades per day. Now, according to AI, this is peak trade updates is at 13 to 25 million, that is 5x spike according to AI generated value. Now, this is incorrect because it is like, AI said peak traffic is 5 times normal. Robinhood's own documentation shows 7.5 times growth in just 6 months during 2020, and GameStop spikes were 10 to 15 times normal. Now, AI significantly underestimated how extreme the peaks can be. This is dangerous. An infrastructure designed for 5x would collapse during real meme stock event. Then we have order latency target. Now, order latency target is 100 milliseconds. Now, this is also incorrect because AI said orders should complete in 100 milliseconds. Now, the real standard for financial trading is under 10 milliseconds. Over here, AI applied a web application standard to a financial trading system. These are completely different categories with completely different expectations. Okay, then we have storage per trade record, that is 10 KB per record. This is also incorrect. AI said each trade record takes 10 kilobytes of storage. The real database row size is 2 to 3 kilobytes. AI confused a lean transactional database record with a full audit log entry. Two different things stored in two different places. Then database recommendation. MongoDB for orders. This is also incorrect. AI recommended MongoDB for storing orders. Robinhood actually uses PostgreSQL, which they have documented publicly multiple times. This is a factual error, no matter of opinion. For for financial data requiring strict transaction guarantees, PostgreSQL is correct. MongoDB was a generic reasonable guess that happened to be wrong for this specific company. Then we have settlement period T plus 2, as we have already discussed before. That is, this is also incorrect. Now, AS said trade settle in 2 business days. The correct answer is 1 business day, T plus 1, which became mandatory in the US on May 8th, 2024. AI training data did not reflect this regulatory change. Yeah, right. So now we have section 3, validation of AI output. Here, every number produced by AI was validated against 3 primary sources: Robinhood's SEC filings and official press releases, Robinhood's just validation for AI output, and Robinhood Engineering Kafka. Just sorry for the interruption. I think validation for output, primary data check, architectural data check, and this. Right. Right, yeah. So, right. So, what I was saying is that every number produced by AI was validated against these 3 primary sources over here: Robinhood SEC filings, the official press releases, Robinhood's own technology blog posts documenting their infrastructure, and independent research from verified industry publications. Now, here is the rule: if a number cannot be verified from at least 1 primary source, it is flagged as unverified and checked against industry benchmark before being accepted or corrected. Now, if I go through this table, this validation framework table, it shows 8 different types of checks performed and what source was used for each. Now, if I go with primary data check, now user numbers like DAU, MAU, that is daily active users and monthly active users, and funded accounts were checked against Robinhood's officials SEC filings. These are the most reliable numbers available. Architecture check, it says that the tech stack AI recommended was checked against Robinhood's own engineering blog posts. This is how MongoDB error was caught. Robinhood blogs clearly states PostgreSQL and Kafka. In regulatory check, this settlement period was checked against SEC government directly. Government websites are the only reliable source for regulatory facts. Then comes incident data check. What we validated over is that peak traffic spike magnitude. Now, in this incident data check, this peak traffic spike estimate was checked against Robinhood's documented real world experience. The Kafka case studies on factorhouse.io confirmed the 7x growth figure with specific numbers and date. So it was documented in December 2019 to June 2020. Now, latency standard check. The order execution latency target was checked against industry standards for retail brokerages. Then comes database check. The database recommendation was checked against Robinhood's technical blog. After clearing documentation, confirmed PostgreSQL, not MongoDB. Then comes cost benchmark check. The AWS cost estimate was checked against similar scale fintech companies. there is no public source for Robinhood's exact AWS bill, so it was benchmarked against comparable companies instead. Then we have formula check. Now, every mathematical calculation AI performed was recalculated manually from scratch. This catches arithmetic errors and wrong formula applications. Now, some key validated facts. Now, this table is your receipt book. This particular table is your receipt book. Every important fact that survived validation with the exact source that confirmed it. Now, 25, this 25.2 million funded accounts confirmed from Robinhood's official data, not an estimate, a reported figure. This 13 million monthly active users confirmed, this 13 million monthly active users confirmed from Robinhood's own quarterly results announcement. This 100k to 750k request per second in 6 months confirmed from a detailed technical case study published by factorhouse.oi documenting Robinhood's Kafka usage. Postgres plus Kafka tech stack confirmed from two separate Robinhood sources independently. The Robinhood scaling block and the Kafka case study. Now, this T1 settlement effective date from May 28, 2024 confirmed from the SEC's own rule change announcement. This application level sharding plus 15 plus Airflow clusters confirmed from Robinhood's own presentation at the Airflow Summit. Engineers presenting their own systems architecture at a public conference. Last but not the least, I think we've missed something over here. PG bouncer connection pooling was also part of it. So this PG bouncer connection pooling confirmed from Robinhood's own newsroom blog post about scaling their crypto systems. The engineering team described this themselves. Here comes section 4, where AI was wrong and how we corrected. 6 specific errors were identified in the AI output. Each is documented with the AI's original answer, the correct answer. This is the most valuable part of this particular exercise. Now, if you go through error 1, that is DAU overestimate. Now, AI said 8 to 10 million DAUs, that is daily active users, but the correction was made and it was approximately 4.7 million daily active users. The reason is Robinhood is not a daily use app for most users. Second error is peak traffic spike too low. AI said 5x peak factor for meme events, which was corrected to 10 to 50x documented. Here, AI used a generic 3 to 5x peak factor, missing the extreme volatility of retail trading events. Error 3, that is order latency requirement. AI said 100 milliseconds P99 order latency, which was corrected to under 10 milliseconds P99 target. Now, Robinhood must execute orders in under 10 milliseconds to compete on execution quality and comply with best execution obligation. AI treated Robinhood like a web app, not a financial trading system. Then comes error 4, that is storage per trade record. AI said 10 KB per trade record, which was corrected to approximately 2 to 3 KB per DB row. AI confused a raw database row, that is 2 to 3 KB for order data, with a full audit log entry that was 5 KB. Then comes error 5, wrong database for orders. AI said MongoDB for order records, but it was corrected to Postgres SQL. Now, Robinhood's own engineering blog, as I've already told you before, and Kafka case study explicitly documents PostgreSQL as the order database. Now, error 6 is outdated settlement period. AI said T plus 2 settlement, which was corrected to T plus 1 since May 28, 2004. Again, according to US SEC, mandated a switch from TW2, T plus 2 to T plus 1. So, as we have already discussed this. Now, section 5, we have final corrected capacity plan over here. Now, this is the production ready capacity plan after AI generated first draft plus human validation and correction. Every number is verified against real Robinhood data or defensible industry benchmarks. Now, if you go over here and talk about the deliverables over here, that is starting with the assumptions. So, if you think about it, what this table tells you, what this particular table tells you. So, this particular table tells that Robinhood has 25.2 million funded accounts, but only 13 million use it monthly and 4.7 million on any given day. Each active user places about half a trade per day, giving us 2.5 million normal daily trades. But on a meme stock day, this explodes to 25 to 125 million trades. All of this happens within 6.5 hours of market time. For every trade written to the database, 10 reads happens everywhere. Every order must complete in under 10 milliseconds, and every trade must officially settle the next business day. So next deliverable is traffic and RPS. So here is exactly how busy Robinhood systems is at every traffic level with every calculation shown. 2.5 million trades happen on a normal day, but they do not spread across 24 hours. Only 6.5 hours of market time, that is 23,400 seconds. This 107 new trade records being written to the database every second on a normal day. The read RPS from trading. People read far more than they write. For every one trade placed, 10 reads happen. Checking order status, viewing history, loading account balance. Now, as given in the calculation, 107 by 10, that is 1070 reads per second, add price check reads. Every active user also checks stock prices during their session, not placing trades, just looking. Let me go through this all over again. What I mean to say, every active user also checks stock prices during their session, not placing trades, just looking. So 4.7 million users into 10 price lookups each is equal to 47 million lookups spread across 23,400 seconds. Now here the number is divided by 23,400, which gives 2009 price reads per second. Now there comes total normal RPS. Now if we add all three together, that is 107 writes plus 1070 order reads and 2009 price reads, which gives us approximately 3,200 total requests per second. Now this is a baseline, the normal Tuesday number. Everything below this is what happens when it gets worse. Peak and extreme, that is 3,200 into 10, which gives 32,000 RPS on a big news day. 3,200 into 50, that is 160,000 RPS on a GameStop day. So this section converts the assumption of 2.5 million daily trades into precise per second numbers at every traffic level, showing exactly how many requests, events, and connections every layer of Robinhood's infrastructure must handle, from a quiet Tuesday all the way to a GameStop emergency. So when I talk about 160,000 RPS, I'm talking about the GameStop day. And when I talk about 32,000 RPS, this is like a big news day. Some like, sentiments of certain stocks going up, or Donald Trump announcing something, related to Iran war. So this is, I would say, a big news day. Okay, in comparison to GameStop meme day. Then we have deliverable 3, storage growth. Now This table shows that Robinhood adds 125 GB of new data every trading day across 5 distinct storage systems. And that portfolio snapshots dominate the total, not because they are large, but because there are 25 million of them saved fresh every single day. Order records 27 GB per day. Every trade placed by every user gets saved. Market data 4.5 GB per day. 10,000 stock and crypto symbols, each sending one price update per second during market hours. Then audit logs, that is 12.5 GB per day. The law requires every trade event to be stored for 7 years. Each audit entry is larger than a database row. Then portfolio snapshots, that is 75.6 GB per day. This is the biggest row and the most surprising. Every single day, Robinhood saves complete snapshot of every account's holdings. Then we have miscellaneous, that is 5 GB per day. Now, this is the buffer of everything else: ML model data, application logs, temporary files, and monitoring data. Deliverable 4, bandwidth. Now, this section is saying one thing: how much data flows into and out of Robinhood servers every second, and what happens to that flow during an extreme event. So, first is market data inbound. First is market data inbound, block 1. This block builds up in 3 layers. Layer 1, basic price; layer 2 with order book depth; and layer 3 with options chain. The reason all 3 layers are shown is to demonstrate how quickly bandwidth requirement escalate as you add more data types. Each layer is more realistic than the previous one. Block 2, WebSocket outbound. 2 million users have the app open watching live prices. Each connection receives continuous price updates for their watch list. 200 bytes every second per user. Now multiply across 2 million users and you get 3.2 Gbps flowing out to phones continuously during market hours. This is the largest outbound flow by far. Not orders, price streaming, only price streaming. Block 3, order API outbound. Now, when users place orders or check orders, Robinhood sends back confirmation responses. This tells you something important. The actual trading part of Robinhood uses almost no bandwidth compared to price streaming part. So what this tells you something important, the something important is that, again I am repeating, the actual trading part of Robinhood uses almost no bandwidth compared to the price streaming part. Trading is 51 Mbps, price streaming is 3200 Mbps. Price streaming is 63 times larger. This is huge. Then we have block 4, that is peak WebSocket. Now, during a major event, more users open the app and prices change faster. Both effects compound. The outbound WebSocket bandwidth multiplies by 10, that is from 3.2 Gbps to 32 Gbps. So this section shows that Robinhood's bandwidth is dominated by 2 data streams: 5 Gbps of market data arriving from exchanges, up to 32 Gbps of live price updates being pushed to millions of open phone apps. While the actual order processing that most people think of as Robinhood's core product uses less than 1% of the total bandwidth. I repeat again: 5 Gbps of market data arriving from exchanges and up to 32 Gbps of live price updates being pushed to millions of open phones apps. So most people think of as Robinhood's core product uses less than 1% of the total bandwidth. Then we have deliverables, deliverable 5, that is database architecture. This table is saying no single database can handle everything. So 9 specialized components each do one specific job perfectly. So like as I said, we have 9 components instead of 1. A small app can use one database for everything. Robinhood cannot. It has 5 completely different data problems happening simultaneously. First, transactional trading data that must never be lost or corrupted. Second, real-time prices changing thousands of times per second. Third, 750,000 internal messages flying between services every second. Fourth, legal compliance data that must be kept for 7 years. Analytics that must reflect what happened 15 minutes ago, not yesterday. So not single database solves all five. So each component in this table solves exactly one problem and solves it better than any general purpose database could. So here the explanation of each component in a plain language. So PostgreSQL, this is the main financial database. PG Bouncer is the connection manager. Apache Kafka, the internal postal system. Redis, the fast answer cache. Timescale DB, the price history specialist. Amazon S3 and Glacier, the legal archive. Confluent Schema Registry, the message rulebook. RAID replicas, the read-only copies. So the question comes, how they all connect? How they all connect. So how the one order, one trade flows through all nine. So here it goes. You place a trade, okay? Then Redis checks your session token and your risk limits under 1 millisecond. Then PG Bouncer grabs a connection to the right PostgreSQL shard and writes your order record. After that, Kafka receives the order event and delivers it to the portfolio service, notification service, settlement service, and the audit service simultaneously. Then comes schema registry, which ensures every service reads the Kafka message in the correct format. Timescale DB records the price at which your trade executed. Then S3 Glacier receives the full audit log entry for the 7-year compliance record. Then step 8 is RAID replicas. Serve your updated portfolio to your screen without touching the primary database. Then Debezium pipeline captures the balance change and updates the analytics data lake within 15 minutes. So here we have section 6, that is the final architecture HLD. Now this HLD is a corrected blueprint of Robinhood's complete system, and the 3 corrections embedded in it are proof that AI produces a strong starting architecture but cannot replace the domain expertise needed to make it production ready. Moreover, the diagram has 4 horizontal layers. Data flows downward from users at the top through the system to the database at the bottom out to external partners. Now, let me explain you the architecture over here. The first one is the client layer. Mobile apps, iOS and Android, communicate via REST for order placement and WebSocket for real-time price streaming. The desktop Robinhood Legend platform uses a more sophisticated fixed protocol interface for active traders. WebSocket connections are long-lived. A user with the app open maintains a persistent connection receiving price updates for their watch list. Then comes API gateway. Every inbound request passes through the API gateway, which handles authentication, JWT validation, rate limiting, circuit breaking, and routing to the correct microservice during the GameStop event. Let me repeat. Every inbound request passes through the API gateway, which handles authentication, JWT validation, rate limiting, that is to prevent the system from being overwhelmed by the single user's automated script, circuit breaking to shed load gracefully during extreme events, and routing to the correct microservice. Now, during the GameStop event, rate limiting at this layer was Robinhood's primary defense against cascading failure. Then we have core services. Now, this table describes 6 services, each with a single clear responsibility and one critical design decision. And the decisions collectively answer the hardest question in building a financial trading platform. What happens when things go wrong? Traffic spikes unexpectedly, 2 million users connect simultaneously, a network call fails, a regulatory rule changes, or a settlement must be completed perfectly by morning. Then we have data and messaging layer. Now, PostgreSQL with application level sharding handles all transactional order and portfolio data. Sharding key is user ID, that is, all orders for one user go to one shard, enabling fast per user queries without cross shard joins. Kafka carries all order lifecycle events and feeds the audit log pipeline. Redis provides sub-millisecond access to session data and current portfolio values. Timescale DB stores all historical market data in time partitioned format. Then we have external integrations. Now, Robinhood routes orders to market makers, direct exchange connections to NYSE and NASDAQ, DTDC for clearing and settlement, SEC for regulatory reporting, and banking partners for hedge fund movement, ACG fund movement. Each of these external connections has its own latency characteristics and reliability requirements that must be factored into the overall system design. Then we have three core questions over here. Then we have three core questions. So in the end, how AI helped, where was AI wrong, how we corrected it. These are the most important questions now that we have to answer. So what really happened on, how AI helped? So I gave Claude 5 specific prompts and AI produced a complete capacity plan. Now, a professional engineer doing this from scratch would take 2 to 3 days, but AI gave us 80% of it in 3 minutes. This is the value proposition. It is not that AI replaces you, it is that AI gives you a starting point that would otherwise take days. The second question is that where AI was wrong. Now, here is where it gets interesting. I validated every single number against real Robinhood data and I found 6 errors. Error 1, AI said 8 to 10 million daily active users. The correct answer is approximately 4.7 million. Error 2, peak spike, AI said 5x, the real number is 10 to 50x. Error 3, latency, AI said 100 milliseconds, Robinhood confirmed in under 10 milliseconds. Error 4, AI said 10 KB per trade record, the actual database row is 2 to 3 KB. Error 5, database, that is AI recommends MongoDB, Robinhood uses PostgreSQL. And in the end, error 6, that was settlement period. AI said T plus 2, the correct answer is T plus 1, mandatory, since May 28, 2024, according to SEC's new rule. And in the end, how we corrected it. So, like, with these 6 errors corrected, the capacity plan changes significantly. DAU drops from 8 to 10 million to 4.7. This halves the traffic calculations but does not reduce the infrastructure requirement because the peak spike factor went from 5x to 10 to 50x. The net effect is that you need less infrastructure on a normal day, but you need far more robust capacity for extreme events. The corrected architecture replaces MongoDB with PostgreSQL. The corrected architecture replaces MongoDB with PostgreSQL. Let me repeat once again what we would like. Sorry for the interruption. Let me repeat once again. So what we are doing over here, how we corrected the AI. So, as I said that with the 6 errors corrected, the capacity plan changes significantly. DAU drops, that halves the traffic calculation, but does not reduce the infrastructure requirement, okay, because the peak spike factor went from 5x to 10x. So the corrected architecture replaces the MongoDB with PostgreSQL, adds T plus 1 settlement constraint to the clearing service, sets the order execution latency budget at 10 milliseconds, and separates the hot transactional storage from old compliance audit storage. Now, this final HLD reflects these corrections. So, here's the complete presentation of Robinhood Capacity Plan with AI. I would say go through this recording again and again. If you have any questions, ask me. And sorry for the interruption if there was a bit of missing things over there. But if you have any issues, ping me, let me know where you got stuck, what you're not able to understand. But do let me know. Thanks for the session.